Hello everyone, today we are going to study about gas law. Describe the behavior of gases under varying condition of pressure, volume, temperature and amount. They are fundamental in physics, chemistry and engineering, especially for understanding gases in industries, process, atmospheric science and even breathing. Gas laws is Boyle's law, pressure volume relationship constant T n. Further equation is mentioned at constant temperature, pressure and volume are inversely proportional. Example: squeezing a balloon decrease volume, increasing pressure. Charles law, volume temperature relationship constant Pn. At constant pressure, volume increase linearly with temperature. Example: hot air balloon raise become air expands when heated. Lessig law, pressure temperature relationship constant Vn. Further equation is the property in T in Kelvin is mentioned. At constant volume, pressure increase with temperature. Example: rise burst on the hot rod if pressure builds too high. Avogadro's law, volume amount relationship constant Pt and equal volume of gases at same T and P temperature and pressure constant contain equal molecules. Example: inflation, a balloon adds moles of gas increasing volume. Combined gas law, integrate Boyle's, Charles and Gay Lessig laws for changing condition. P1 V1 by T1 is equal to P2 V2 by T2. Useful when P, V, T all vary but amount N is constant. Ideal gas law, universal equation combining all gas law. PV is equal to constant and RT. P is pressure and V is volume and N is mole of gases. R is universal gas constant. Mole K or 0.082 1 L, and T is equal to temperature, which is equal to Kelvin K and 0 degree centigrade plus 27 plus 15. Real gases versus ideal gases. Real gases are particle have no volume, no interaction, and real gases deviate at high pressure, P molecular volume matter, and low T intermolecular forces. Van der Waals equation corrects for real behavior. P plus En2 by V2 and V is equal to minus NB is equal to nRT. Where A is attraction between molecules and V is molecular volume. Important concept: STP, standard temperature pressure. 1 mole ideal gas occupies 22.4 L at STP, standard temperature pressure. Partial pressure, Dalton's law. Example: air pressure, sum of N2O2 C2 and partial pressure. Kinetic molecular theory, K empty gases, tiny particle in random motion, collision or elastic average. K is equal to proton T. Application in Pakistan context. S-cube diving, Henry law, gas solubility in blood, N2 narcosis, risk at depth, high altitude cooking, lower P, reduce boiling point, food cooks slower in mountains like Gilgit. Industrial processes, compressed air system, gas pipelines, natural gas transport, VSUI, northern gas pipelines. Weather balloons, measure speed, TP, pressure, temperature, volume changes to predict weather in Pakistan, diverse climate. Common mistakes are forgetting to convert C to Kelvin, Using R with mismatched units, assuming ideal gases for gases at high pressure or low temperature, use van der Waals for real gases. Pakistan curriculum exam tips. Derive gas law for kinetic theory. Solve numerical using PV is equal to nRT and combined gas law. Explain real gas deviation in particle scenarios, compressed cylinder gas liquefaction. Want to solve specific gas law problem like finding volume at STP, calculating partial pressure, or applying van der Waals. Derive gas law from kinetic theory, solve numerical during PV and RT, and combine gas law, explain real gases deviation in particle scenario, compressed cylinders gas liquefaction. Wants to solve specific gas law problem like finding volume at STP, calculating partial pressure, or applying van der Waals. Or explore how gas law apply to breathing engines or weather system in Pakistan. Want to solve the specific gas law problem like finding volume at STP, calculating partial pressure, or applying van der Waals. Or explore how gas law apply to breathing engines or weather system in Pakistan.